Okay, here are the bell ringer problem answers. So I line these up vertically instead of horizontally so I can do the subtraction more easily. So 9 minus 8 is 1, 6 minus 3 is 3. 69 minus 38 is 31. 2 minus 4, well, you can't do it, so you do have to borrow here. Now, 12 minus 4 is 8, and 7 minus 7 is 0. 82 minus 74 is 8. 177 minus 63, 7 minus 3 is 4. 7 minus 6 is 1. 1 minus nothing here, so 1. 144. 451 minus 268, I do have to borrow again here. 11 minus 8 is 3. 4 minus 6, can't do that one either, so I borrow again. 14 minus 6 is 8. And 3 minus 2 is 1. Now that you've gotten all the answers to the bell ringer problem, you should probably head over and take the quiz right now before you forget. All right, this is lesson 1.2. We're still talking about integers, and it's on page 10. So if you're following along, page 10. And it says adding integers with the same sign. So here we have two positive integers, and here we have two negative integers being added together. So that's what they mean by the same sign. It says add the absolute value of the integers, then use the common sign. So here, 2 plus 5, well, the absolute value of 2 is 2, and the absolute value of 5 is 5. So you add those. You get 7, and you keep the common sign. Well, they were both positive, so my answer is positive. We've been doing that all our lives. So that one's pretty obvious. Over here, this is kind of new, but we look at it. We have -2 and -5. So we look at their absolute values, or look at the number parts, 2 and 5. We add those together and we get 7. But then we have to keep the common sign, a negative. Here's a negative, so we keep the common sign, which is negative. We make it -7. Well, another way to say this is when it's the same sign, add and keep. Add the number parts, keep the sign. Add the number parts, keep the sign. So let's look here. Adding integers with the same sign. Here they're using a number line to do this. So they've got -2. So you start at 0 and they move -2. And we're adding to that a -4. So when we're all done there, we've actually moved -6. When they put a -2 together with a -4, they get a -6. So they check their answer on a number line. Here are some problems for you to do on your own where you're adding the same sign. Okay, here are those on your own problems 1, 2, and 3. Remember, we're adding integers with the same sign. So we add the number parts and we keep the common sign. 7 plus 13 is 20. And they were both positive, so my answer is positive. I have -8 plus -5. So they put this one in parentheses here, so we don't have -8 plus -5, and it would be a little confusing. So they put this in parentheses so you knew it was a negative. So -8 plus +5. -8 plus -5. The 8 and the 5 make 13, so I add the number parts because they're the same sign, and I keep the sign. -8 plus -5 equals -13. Sometimes I like to think about it like if I have a group of 8 negatives and I add 5 more negatives, now I have 13 negatives. Here I have -20 plus -15. Same sign, so I add and keep. Add the number part, keep the sign. Same sign, add and keep. Well, moving on in the lesson, we come to a part here that says two numbers that are the same distance from 0, but on opposite sides of 0, are called opposites. For example, -3 and 3 are opposites. All right, the next key idea here, adding integers with different signs. So now it says subtract the lesser absolute value from the greater absolute value, Then use the sign of the integer with the greater absolute value. And that might seem a little confusing, but we'll do a couple of them and you'll figure it out. So 8 plus negative 10. Notice, different signs. I have a positive and a negative. So what I do now is I subtract the number parts. And 10 minus 8 is 2, so I get a 2 over here. And I keep the sign of whichever number part was bigger, the greater absolute value. So the 10, there are more negatives here, so it wins and it gets to keep its sign. Over here I have negative 13 plus 17, different signs. I have a negative and a positive. So I subtract the numbers. 17 take away 13 is 4. And which one had more? The positives had more, so it gets to keep its sign. Positive 4. So remember, it was same sign, add and keep, and now we have different signs, subtract. Okay? So same sign, add and keep, different sign, subtract. Keep the sign of the bigger number. The additive inverse property states that the sum of an integer and its additive inverse, or opposite, is 0. So 6 plus negative 6, 0. Negative 25 plus 25, 0. And then over here it says algebra because we're not using numbers here, but a plus negative a. We don't know what a is, but I have the number here and its opposite. And whenever I add opposites, I get 0. Okay? So, and it makes sense because, look, they are different signs. So I would subtract them. 6 minus 6 is 0. And I wouldn't keep either sign because they're the same absolute value. I wouldn't keep, aren't more positives. There aren't more negatives. So therefore, 0 is neither negative nor positive. Here are the answers for the on your own 4, 5, and 6. Negative 2 plus 11. Different signs, so I subtract the number parts. 11 take away 2 is 9. And I keep the sign of the larger number. 11 has more positives than the 2 has negatives, so we keep it positive. 9 plus negative 10, different signs, subtract. 10 take away 9 is 1. And we keep it negative for the 10. Negative 31 plus 31, different signs, so I subtract. 31 take away 31 is 0. Oh, I should have known it was 0 because they're opposites. And anytime you add opposites, you get 0. And I don't put a positive or a negative out here. It's just 0.